So, on your schedule it says George Moore, Atlas Components and so forth, and George Moore is my boss, and I'm here at his request to talk more about language type stuff. My background is formerly chief scientist at Borland in the Delphi compiler group, now with the Windows Live group. And paradoxes in Windows development, in web app development, having come from a strongly typed language, a structured environment, rather rich set of tools, and now to be working in the web app client-side development space is quite a shock. And what I want to do in this session is to relate some of the shocking news that probably everybody already knows about to you guys as language developers to think about pitfalls to watch out for in your own language development, and also opportunities for things that you can do with your language, perhaps in a space that you haven't thought about before, which is web app development. Corollary to this title, couldn't quite decide on a fun title or a boring title, so the fun title is Cobbler's Kids. Where are my shoes? Here we are, one of the largest deployed application platforms ever known to man, the browser. And the development tools for doing web apps are abysmal compared to all the other development systems you've got. So very briefly, the various kinds of application development models. We have the static content, just HTML sitting up on a website, not a whole lot of interactivity. Server-driven dumb client, where the server is just sending you forms, you click a button, it goes back to the server, comes back down with a new UI, back and forth. Okay? Server-driven rich client, which is still primarily server-driven, that the server is in control of the conversation, and it is making use of smarter controls that are down on the client. Atlas is an example of this. ASP.NET applications are very typically server-driven smart clients. Okay? Your reach in terms of your applications is fairly broad in these cases, but the server that you can deploy it on is very specific, that it needs to be an ASP.NET type server. Another case is the client-driven user experience, where the server piece is just file serving. You don't actually need any intelligence on the server. All of the intelligence is in the client, or the majority of the intelligence is in the client. And examples of this would be JavaScript apps, Flash type applications, things like this. And then for completeness, a net-connected standalone app, a CLR or Win32 application that's connected to the network is a type of web app, but it's a very large hunkin' piece of code down on the client that has some web connectivity. Now each of these has a different reach and a different server requirement. So very quickly, I'd like to touch base on where I'm coming from in all of this stuff. Windows Live is the collection of a lot of the online consumer-facing services that Microsoft has had for years. MSN Search, Spaces, Hotmail, Virtual Earth, and these have been brought together into the Windows Live, under the Windows Live umbrella. And dev.live.com is where I live in building SDKs and experiences for developers to leverage that consumer market. So there's consumer-facing side of all of this, and then there's the developer APIs to get to those services. If we dive into one of these, just as an example, the Virtual Earth, if you go to local.live.com or search, that'll bring up something that's built on Virtual Earth. Here we have, because of resolution, it's been slid down a little bit. We have a Virtual Earth map and sort of a cookbook menu over here. This is actually the Virtual Earth SDK. You click on the item, I want to show it at a specific location, and it takes the map to the Space Needle in Seattle. And if you want to see the code on how to do that, here's the JavaScript code to do that. Very straightforward, font's okay. Basically, in your HTML, you define a div section with an ID. Doesn't matter what the ID is. You need to include some JavaScript code to pull the client control for JavaScript for the Virtual Earth map control into your application. And then you construct the Virtual Earth map, and you give it a latitude, longitude to display itself. Okay. Another example, a little bit more coding is using push pins. Put a default push pin on the middle of the map. Scroll down a little bit. There's the push pin. Got a little bit of flyover. Source code for that again. Same system. Add pin. We have constructing a new push pin. This is coming from the Virtual Earth SDK. Map center to get the current latitude and longitude of the map, and a little bit of text that gets displayed on that. So this is examples of what we're talking about with the client-side development, that a lot of intelligence is being pushed down into, or a lot of the capabilities are being pushed down into the client to take advantage of the processors that are out there running the browser. So, Windows Live is very much about this client user experience and primarily JavaScript, although a lot of those SDKs also have SOAP APIs, so you can get to them from standalone apps. My primary focus is JavaScript. So, what are the strengths of JavaScript? I mean, how many people are familiar with JavaScript in general? Okay, good. Let's go fast. Then you'll really like the next slide. So the strengths are primarily ubiquity. I mean, why do you use JavaScript? Because you can reach a very, very wide audience very quickly. It's in all the browsers, it's in all the platforms, etc. It's easy to get into. JavaScript is easy to figure out. You can go look at somebody else's page, view source, cut paste, and now you're doing what they were doing. Isn't that kind of cool? Never mind about the lawyers. The tool requirements are very low. You can do JavaScript programming with Notepad. And basically the state of the development environment is that that's not much more than what a lot of the other development environments are. Client-side aggregation. That JavaScript enables you, manipulating the DOM, that you can build chunks of code on your page that are coming from different domains. Now, because of the browser security model, those things cannot talk to each other. And that's something I'm going to come back to a little bit later in this talk. But it's actually a strength that you can aggregate things together from different suppliers. That's something that we would like to see more of and provide a little bit more fine-grained control of so that we can bring things together as building blocks. JavaScript can access the HTML DOM. What was mentioned in an earlier session, I think yesterday, is that the DOM is basically data flow. It's a big chunk of network data, and that's very true. The counterpoint to this on the next slide is that the DOM is just data. There's not a whole lot of control involved in that. We'll get to that. A strength of JavaScript is the strong sandbox, that you can have a fairly high degree of trust that your JavaScript, if you're a consumer, that this JavaScript stuff is not going to completely obliterate your machine. Now, of course, there are exploits and there are holes that have been patched, etc. But primarily, it's a very different message from downloading an exe. Huge difference in trust level. JavaScript, as an advantage, does have garbage collected heap as opposed to manually freed data, freed memory. The caveat is that the garbage collected heap is a most of the time kind of thing. That it's not as fine-grained and not as smart as the CLR memory collector. It doesn't recognize loops and so forth as being something that could be freed. And ubiquity is, again, another strength. Pain points. One of the biggest problems with JavaScript overall is that while it's easy to get into, it doesn't scale well for large applications. The global namespaces, the lack of source referencing between source modules means that the thing that drives the entire application is the HTML. So if you're writing a library that you would like to treat as a black box, the third party can just reference your library and begin making API calls. You either have to do some pretty dirty hacks to figure out how to get your source code to reference other source code, or you have to tell your consumer, the developer that's using your stuff, that they have to include 15 JS files to use your stuff, or you have to mechanically just glom all your stuff together and throw it out there and say, here's your one file to reference. Now, these are not terribly attractive options. Because of this, a lot of, and related to this, that there's a lack of modularity, lack of encapsulation. It's difficult to build a box of code and provide a surface that is facing the developer, facing the consumer of this, and isolate your internals. Again, these are things that, coming from more structured, more traditional languages, you just take for granted. When you get into JavaScript space, it's a bit of a shock. In JavaScript, the ability for script in one area of code to stomp on properties that were created by another part of the code is considered a feature, rather than something that should be flagged as an error. This brings up the requests that you see on the news groups occasionally that wouldn't it be nice if there was some way that I could seal this object instance and not allow any further modifications to it? If I'm adding a property to an arbitrary instance named foo, how can I prevent another body of code from adding a foo property which isn't mine and overwrites mine? Debugging these things is a nightmare. Tool support is fairly poor. I use Visual Studio a lot, primarily because it's the better debugger that I've been able to find. Vinkman is available for Firefox. There's also a Firebug, but quite frankly, Firebug's evaluator falls over the first time you use it, and Vinkman does a lot of good debugging initially, but again, when things get really weird, Vinkman says, I give up.
Now, you're referring to server side.
I'm referring to client side.
We're still talking about client.
I am entirely talking about client side. The server provides files for me. That's my view of the server. Now, if you look at something like Atlas, where you build the app on the server side and it sends pieces down to the client, that's a different model of app development. One thing that's very interesting to me about Atlas is something called atlasruntime.js. It provides a lot of services on the client that I'm interested in as a client-side developer. I'm not all that interested in the server-side stuff. Okay, so debugging services for the client.
So, and these are interactive. These are interactive applications that
Sure.
you are building.
Sure.
You're just moving a lot of the processing or work.
Yeah. Let me show you an example. So let's go to live.com. Live.com, again, is a consumer-facing homepage builder, web page builder kind of thing. Come on, network. Ding, 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 ding. There we go. So live.com, we have all of these boxes on it, and these are feeds coming from different locations, right? And a server-side application is not going to allow you to do this, right? This is client-side. This is interaction in the browser. What happened to Reuters? There we go. Now, what's interesting about this, we're talking about client-side aggregation. This looks a lot like what, in the old days, would have been called a website portal, where the portal would be a server that pulls these various feeds of data from their various locations, builds a giant HTML file, and sends that to the client. Now, what use is that to the client in terms of end-user configurability? You can't take apart that HTML very much. This page is actually primarily feed-oriented. That live.com hosts a wrapping HTML page and a couple of indicators of iframes and some personal preferences, and then all of the other data comes from these various other sites, other domains. So directly to the client. So
is it view source?
Sure. So you say view source. There's going to be a lot of gobbledygook in here. The live app. The point being that you're not seeing Reuters in here, right? Now, this is actually built using Atlas, so this is an Atlas application. Where'd my mouse go? But the key point being that this is client-side aggregation. That live.com server gives us an HTML page that instructs the client to go pull data from other sources. So when we hit the refresh, you saw these coming in at different times. That's because they're coming from different servers. And so we're talking about client-side aggregation. For your server, in the old portal model, one of the problems was that your server was receiving a request, going out and fetching data from multiple locations, and then sending it back to the client. Well, that data has crossed your network, your routers, 3 or 4 times before it gets to the client. So you got a pretty heavy traffic load. With this thing, the aggregation is being done by the client. The data flow is at the client side. Okay, so JavaScript on the client, because of the lack of modularity, because of the lack of source-to-source references and so forth, JavaScript becomes increasingly difficult to deal with the larger and larger the application gets. And most of the large-scale applications that you see out there in the wild today, things like Gmail and Hotmail and whatnot, are built using aggregation tools that will produce a monster JS file that gets delivered to the customer. People don't actually write the JS file at 150K at a time. They get glommed together using tools. One of my pet peeves that you'll hear about many times is inter-element communication. I come from a background of Delphi, VCL, .NET Framework, also called FCL, and all of the components and objects in these frameworks can talk to each other. And that there are messaging mechanisms, there are delayed message mechanisms. You have none of that in the browser app space. You have function calls. That's it. And that's an area I think we can do some massive improvement. Concurrency. JavaScript is, by definition, single-threaded. And a lot of the folks in the browsers, the browser teams, are very religious about, oh my God, don't even begin to talk about threads. They're really scary. But the fact of the matter is everybody talks about JavaScript being an asynchronous supporting language, that you can have asynchronous callbacks, yeehaw. Fact is, all that means is deferred execution. It does not mean concurrent. And that means that you can have a whole bunch of asynchronous things queued up, but if your JavaScript code doesn't eventually return to the browser, nothing happens. You have to go back to the message queue, just like a Win32 app. You don't have the message queue in your app, but you have to relinquish control. This also means that web apps, as currently implemented in the browsers, cannot fully exploit the multi-core clients. The processor people have told us that they can't. There's no more up on processor speed, that they're doing wide instead, and the only way you can fully use all of that CPU power is to be able to do threads, somehow. So we have this paradox, the ubiquity paradox. JavaScript is everywhere. It's a very attractive platform. It's easily accessible. It's easy to deploy to. But everybody complains about it. Everybody grumbles about it. And the fact of the matter is, we talked about you heard a session the other day about long tails, that JavaScript and the browser space have so much momentum, so much inertia behind the way things are. It's very difficult to turn that ship. If we went through and started a standards body initiative to implement a new feature, and then work with all the browser implementers to get that feature implemented, how many years would it take to actually see that in the field to a sufficient degree that you could call it reliable and ubiquitous? It's a long time. Look at, for example, XML HTTP requests. It became popular, got into the popular mindset about 2004. They actually got a catchy moniker around 2005. The fact of the matter is it was deployed in 1998 in IE, or with one of the Outlook add-ins. So it takes quite a while for these things to come together.
So question.
Yes.
The difficulty or the bugs that exist, do they exist in JavaScript or the browser? The difficulty with debugging,
right?
Objects getting stepped on in the address space.
So the fact that JavaScript allows you to modify or add an arbitrary, repeat the question. Are the bugs and issues that we hear about in web apps, are these JavaScript themselves, or is it in the browser or in something like that? And it's a mixture. The part about JavaScript allows you to, just by the fact that you've referred to a property of an object, if it doesn't exist already, JavaScript will create a property there. So that means if you have a typo, there's no compiler error. There's no lint that says you've made a mistake. It just says, okay, we'll call it LIEK instead of LIKE. I don't care. Or if there's already a property there that you didn't create and you're putting a different kind of value in it, JavaScript says that's okay. That's a JavaScript issue. Things like the security barriers between iframes, that's a browser thing. Being able to do certain things with the DOM, that's a browser thing. So it's multiple concerns. Yes?
You said that JavaScript is not current, so you say that if you do a bunch of set timeouts and your page and your client also all these set timeouts are calling out, that really they're all synchronous, they're just all queued up waiting for execution.
Correct. The question is set timeouts and set intervals. If they're in a, do they pile up in a queue and then they all execute in sequence later? Yes. That if you have a compute cycle or some sort of infinite loop in your JavaScript code, the browsers actually have some bailout points where they say, this is taking too long, you're dead, because they don't want to freeze the browser. But yeah, you can have legitimate JavaScript code that will give you a UI freeze in the browser, even before those bailout points. And you have to worry about starvation with your timers. If you have a lot of very fast timers, you can starve the message queue, and some of them won't ever come through. Gee, sounds like Win32, doesn't it? Okay. So let's look at JavaScript at a very high level, loosely typed. It's got a pretty good set of core primitives, broadly available, easy deployment target, multiple implementations out in the field, and there's slight quirks in the variations between those implementations. We're talking about the browsers here, Firefox, IE, Safari, and Opera, the big ones. Each of those have slightly different implementations. Most of the differences are in the way they do the DOM, not in the JavaScript language itself. The DOM is where most of the differences show up, because that's more representative of their overall architecture. Inertia, that JavaScript is big enough that it's not likely to just disappear. It's going to be around for a very long time. It's also kind of hard to turn, hard to change. If I seem like I'm harping on that hard to change thing, it's partly because of my background. I came from a proprietary programming language where we could change whatever we wanted as fast as we wanted. We changed it really fast. JavaScript being difficult to debug, you have to really have some arcane skills to see what's going on inside the machine. And JavaScript is hard to manage at scale. Now, I put these up here as a list for one reason. It bears remarkable resemblance to something else. Yes? No? Any challenges on this? Intel assembly, loosely typed. Register sizes are really the only thing that matters. Core primitives, broad availability, multiple implementations with quirks, different vendors, different feature sets within the chipsets, not likely to disappear. Assembly has a reputation for being difficult to debug. Again, you have these folks that build up an arcane knowledge of how to read the hex views and so forth. I never thought it was a problem, but and hard to manage at scale. You'd have to become some kind of nut and zealot to build an entire application in assembly. Some people do, but you would focus on doing assembly at a specific place. But gee, there's a lot of similarities here. It raises a question. What if you were to look at JavaScript not as a programming language, because humans really have issues with JavaScript, but what if you look at JavaScript as a virtual machine? JavaScript the IL. An open question. I don't know where this is going, but what if you could take higher level languages which provide modularity, human-friendly, strong debug tools, manageability at scale? These are a function of the higher level language. And crunch that down to machine code, call it JavaScript. Some early examples of this are Nikhil's script Sharp for C# to JavaScript. And I don't know if he's here today or if he's here at all. I'd like to meet him sometime. And also Google's GWT, which takes Java to JavaScript. Both of these have the delicate task of trying to implement semantics of one language on top of the semantics of another language, on top of a language that doesn't have a whole lot of semantics. So you worry about performance, of course, but you also worry about semantic equivalence. And I have some background with that in implementing the Delphi language on top of IL, because Delphi, the language, has some things, some notions in it that IL and CLR do not implement. So we had to implement them on top of CLR, which took some neat tricks. But then there's another whole level. I mean, this language-to-language translation is difficult to get the semantics just right. There was a talk yesterday on text-to-text translation or language translation, and one of the parts where it began to fall apart is preserving exactly the semantics all the way across. One way that you might get better semantic preservation is something that Eric's been talking about, is taking, what if you were to take the IL itself, decompile the IL, which are very primitive little instructions with some semantics around them, and ship those out as JavaScript. Now that's a pretty radical idea, which makes what I thought was a radical idea a much smaller little thing. So I'm all behind Eric on that one.
Finally, somebody.
So in my view, the taking IL and shipping it out to JavaScript is an enormous task compared to just language-to-language stuff. But it seems to me that you're more likely to get the semantics that you were expecting at your high-level language because you're doing a machine-level translation. Question mark still there for performance.
Well, I don't get it. I'm not making
Yeah.
that connection.
Why would you want to do this?
Why would you want to do that?
Okay, so you're writing an application, and the first question you have to answer today is what platform are you going to target, because that's going to limit your audience. The JavaScript, the web browser, is the largest audience of any of the app development platforms. The problem is that you can't put a custom language out there in the web browser very easily. You have to talk about doing downloads, and immediately that shrinks your audience by an enormous amount. So anytime you're talking about ActiveX controls or binary deployments, even Flash itself. Flash has got a very wide distribution for an add-on, but it's much smaller than the browser space in general. So if you're wanting to reach an audience like the Hotmail group or the Messenger group or something like that, we're talking 240 million consumers a month, unique IDs. Hundreds of millions of people, not just tens of millions. This is all about breadth, reach.
Right. It's just that JavaScript, I don't know, just from my experience, it just doesn't have a lot of the, or enough of the constructs that you need in a higher level language.
Right. So the question or observation is that JavaScript doesn't have the higher level constructs and control that you need to build good applications. Exactly. Which is why this sort of raises the question of, well, maybe we just accept JavaScript for what it is, quit complaining about it being not the high language that we want to work in, and I'm talking about me complaining about the high levels, and let's work in a high level language that does provide the things that we want, and machine translate them down to a raw level that JavaScript can handle. There's not that much difference between what you would have to dumb down a high-level language to JavaScript as compared to a high-level language to IL or to Intel assembly. Actually, more like Intel assembly, because IL preserves a lot of type. Where do you draw the line between the JavaScript and the browser? Where that line gets fuzzy is not in the language constructs, not in callbacks and timer messages and things like that. It becomes fuzzy when you get to the DOM, because the DOM, the HTML and dynamic HTML stuff, is a reflection of the internal architecture of the browser. It's very difficult to keep those separate. So on IE, when you want to refer to a particular property of the window object, well, that's the way it's implemented in IE. That same property may have a different name in Netscape or in Firefox. So the fuzziness comes in as you get higher away from the language and more into the library. Yes. 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 So the observation is that somewhere along the line you have to say this is where security belongs, this is where this feature set belongs, and we're actually pursuing that today in the libraries. The Atlas library, the Gadgets SDK provide, for example, something to bridge the differences between how to handle events. In Firefox, you subscribe to an event using this technique. In IE, you subscribe to an event with a completely different technique. And in the Atlas and Gadgets SDKs, you use the library's technique for subscribing to an event, and inside it handles the platform-specific details appropriately. So unfortunately, it means defining a third model, but at least it can bridge those two. Yes?
If you layer up a new language on top of JavaScript, would that mean would you use Xlink to go on top of the DARM?
So the question is, if you were to put a new language on top of JavaScript, could you use Xlink on top of the DOM? Well, at that point, when you're talking about having your own language on top of JavaScript, how you decide to build the world and the runtime interface that you decide on is completely up to you. So yes, you could use Xlink to isolate your language from the details of the DOM. That's a choice that you could do.
So you guys tried to build, like, on the IL idea, like a IL interpreter on top of JavaScript?
I wouldn't go for an IL interpreter, no. And I want to dig in more into the JavaScript interpreter space because I've seen a little bit of the Mozilla stuff, and I'm kind of interested in some of the things that they surprisingly aren't doing as far as performance there. I've also been just heard a conversation earlier today that the performance differences in JavaScript between, say, Firefox and IE is actually more in the DOM than in the JavaScript. Counterintuitive. So, some performance benchmarks need to be run and actually measure these things.
I have just a comment on that. Just yesterday I was doing some micro benchmarks, and the common knowledge is that IE is slow.
You were the conversation I overheard. So go ahead.
So IE is much slower at the DOM level, but pure JavaScript, just doing array indexing and assigning a variable or a method field, IE is actually much faster. So, but
Yep.
if somebody's doing this, it's going to have to take those things into account.
And part of the reason, perhaps, that there is that difference when you get to the DOM level may be because of either the techniques or the way that the various browsers are going about checking security levels and things like that. Yeah, it very well could be iDispatch. But I think that in general, there's only one direction to go is up for JavaScript execution itself. I mean, what would happen if we were able to get a CLR backend inside of the JavaScript engine? That would be kind of interesting. And then we could talk about some JIT type performance. So, topic change. Put away the JavaScript as a platform. Client-side communication. The browser environment, we're going to say JavaScript in general, but the browser environment is heavily biased towards server-client communication. That there are various mechanisms for the client to request materials from the server. There's mechanisms for the client to send some forms or whatever to the server. But it's all very much network focused. Compared to something like VCL or the .NET Framework, where you have communication between objects in several different ways of communicating. DHTML, you can do some tricks with modifying the page on the fly, where you can actually have script that says, okay, change the contents of this div section to this, or change the URL of this iframe to point to a different URL, and the UI changes. It's a dynamic, nearly self-modifying code type paradigm, with all the caveats that go with it. XML HTTP request sort of grew up out of necessity so that script could request data in the background and not interrupt the browser and not actually require a UI element to do this work. An HTML HTTP request, oddly enough, I would guess that more traffic goes through XML HTTP request that is not XML than what its name says. I'd say the majority of traffic is either raw ASCII data that's pre-formatted and everybody knows, somebody knows exactly what they're expecting to get, or it's JSON, which is a JavaScript array type thing. The reason for that is because XML is almost 3 times larger than JSON equivalent, and it takes a lot of processing power to grind through that stuff. So, client-side communication barriers, things that are inhibiting us from doing client-side communication. Again, the inter-element communication, being able to have a chunk of code that's in this iframe says hello world to a chunk of code that's in that iframe. Says, hi, would you mind showing such and such? Or, hi, do you know who the current logged in user is? Having these pieces talk to each other. Now, if you're just writing an app, if you're just writing a monolithic application, why do you need a framework? Why do you need to have components? The point is not writing monolithic applications. The point is bringing the notion of component-oriented development to the client-side development. So another aspect that's a risk in JavaScript I forgot to put in the slides, when you have an HTML page and you include a JavaScript file from another domain, you're bringing somebody else's executable code into your web page and into your domain. That's a potential risk for somebody having hostile code that can go grab other things that are in your domain. When that same reference sits inside of an iframe, it doesn't have access to your domain. So there's a compartmentalization there. That's actually a strong feature. In this particular slide, client-side communication, that iframe is a massive barrier that we can't talk through. The DHTML self-modifying code is quicksand, particularly if you're trying to debug anything, because the source code that you wrote on disk is not the source code or not the script that's actually sitting up in memory. So you have to be you have to have an enormous amount of state management to keep track of what's going on. The browser has special rules about what web pages you're allowed to access from within a particular domain, and the rules say that you can have access to third level or higher domains from a root domain. So Microsoft.com, HTML that sits in Microsoft.com should be able to access a web page that's in subdomain.microsoft.com, right? Or vice versa. Yeah. XML HTTP request does not follow those rules. If you're sitting on dev.live.com and you send out an XML HTTP request to live.com, it will fail because XML HTTP request, XHR, requires an identical match on the domain name. For smaller domains where you basically just have the front door and that's about it, that's not really that big of a deal because it's your entire domain. But for larger domains like Yahoo, Google, and Microsoft, you've got hundreds of subdomains for each separate technology or each separate department. And you want to have them talk to each other. And you can't do that with XML HTTP request. What you wind up having to do is implement proxies on your server that will bounce the data back and forth a couple of times to get it in the right location. As of middle of April, I noticed that the W3C has begun a conversation about how to potentially extend XML HTTP request so that it can, under the right circumstances, be allowed to talk between domains. That's a good first step, and I'm strongly behind that. Ian Hickson has the prototype up there, and I'm very much behind that. But my one mark against it is that it's still client-server communication. It's not client-to-client. It's not self-reference type communication. So what we need, in my opinion, is, whoa, off the top of the screen, client-side inter-element messaging that happens on the client. If we had some way to safely punch a hole between two iframes where both ends agree that it's okay for us to communicate because I know you and you know me, and we set up the communication protocol so that we can eliminate the risk of an observer or of being replay attacked or hacked or something like that. Basically all the protections you have to put onto a network protocol anyway. That if you had the ability to do a post message within your DHTML, what kind of services and implementations would that open up inside of your web app? It would be a catalytic enabler. We do have function calls between bodies of code, but by nature they have to be cut off between areas that need to be secured. Well, messages don't imply code, they imply data. And so you have a little bit better opportunity to say, okay, this data can be transported across the barrier. Because the worst that could happen is the other side reads it and decides to throw it away. Okay? Or the other side is going to be is responsible for handling that data carefully. This, I believe, is going to be critical to building out the web platform to enable semi-autonomous components that can talk to each other, that you can talk about having a component from vendor A and a component from vendor B living on your web page, and having these guys talk to each other in a way that you control, and the way the end user has control over the flow of the data. To do this, I need to dig a little bit more into the specifications. I'm not sure if this is already enabled. But we need a way to address an individual element on the page through a URL. You can sort of do this with anchor tags, but what I specifically don't want to have is get a document get element by ID, because I'd use all over the place, and God, I hope the thing's fast because everybody uses it. I'd much rather just have a reference. Also, because get element by ID is going to be giving you the actual object reference, or the actual object element. And there are many places in the DOM and in the security model where you should not have access to that thing directly. But we'd be happy to give you a message. That's what I'm looking for there. Again, mutual cooperation required between the endpoints, that the receiver should be able to refuse a connection from a particular sender if they don't know who they are, and specifically to avoid strip mining. You don't want to have an iframe on your homepage that has your bank statement on it and have a malicious thing in another iframe that says, "Rip, we've got your bank account." The current iframe model, the current security model, prevents that. And we have got a lot of code out there that's relying on that particular wall. So we need to be very careful about how we approach this communication between pieces. And then this inter-element messaging still needs to be hardened against attack and spoofing and replay and these types of things. Shared secrets going back and forth, so that if you receive a message from me, you know that it was from me and not by some spoofer. So, for you guys, the language implementers, the tool implementers of the world, help me out. How can you give some thought to how you can get your languages to address this web app market? Perhaps you haven't even given that a whole lot of consideration. That you can build applications that target the browser rather than a particular operating system. The web is the operating system. That's what we're trying to build out. How can your tools, for the tools vendors, how can your tools, please, 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 give us better JavaScript or better web application development tools, especially for debugging and profiling? And then collectively, how can we drive standards and implementation in the various browser providers and get things to a better state within our lifetimes? Yeah, you like that little suffix, huh? So some resources, dev.live.com. Go out there and surf around, see the SDKs that we've got for web services, handling hundreds of millions of customers a day. I've got a blog out on MSDN. And if you want to chat about these kinds of ideas or just tell me that I'm a total idiot on some of the JavaScript stuff, send me an email. I welcome comments, questions, suggestions, crazy ideas. Okay, questions?
What's the topic then? Cry out of Microsoft for help by Microsoft?
No, it's cry out for help from Danny. Because there's a lot of Microsoft people here too that I'm crying out to.
For example, regarding debugger, yes, it should be much better.
But there's more than just one debugger in the world, and I would like to get all of them on board. Perhaps an anachronism about the Windows Live group is that Windows Live is given the charter to go out and embrace all comers, all clients, all customers, all consumers. So it's not about Windows platform. It's not about the operating system. It's not about VS. It's about the web. And so, that's not the typical Microsoft message. And so if Vinkman turns out to be the best way to debug scripts, great, I'll use Vinkman. I don't care. I have to get these apps done. What browsers does Windows Live and subdomains work on? IE 5, 6, and 7, Firefox 1.5, and later Safari. I think Safari got that update done. I'm not quite sure about Safari, but Safari is definitely our target, and I believe Opera also. I know that we're in good communications with Opera and Firefox, and I know that we have a contact at Safari. They tend to be a little bit standoffish, but a lot of communication flying around in all directions. Oh, we also have communication with the IE folks, but more often with Firefox.
Hey, Danny, let me play devil's advocate
Absolutely.
for a second. It sounds like your talk focused on entirely client-side functionality, client-side communication. and depended upon the server very little. Wouldn't that problem of communicating between the two iframes disappear if that was that communications was done on the server?
Yes. So the question is, I've been talking about client side only. If we could bring the server back into the picture, would that help alleviate some of these issues? And the answer is absolutely yes. And that is the technique to work around this now. Problem is that it takes a round trip.
So you look at it as a workaround.
I see it as a workaround. And because you're having to go out to the network, the data has to go across the wire twice, and you've got latency. So it's a user interaction aspect as well. There's also an element of all of this where I want to try to break away from the server, because I think eventually someday we're going to be talking about web applications that can live in a partially connected world, that they don't have to have an online high bandwidth connection to exist on the desktop.
Right. Well, my development shop is I think it's typical where very interactive web applications where the user goes to a screen and it's very context. It's things that they click on, things that they populate affect other fields or other
Right.
controls on their screen. So the trip has to be made anyway.
In that case, yeah, you're true. That's right. There's a wide variety of applications that are currently being built on the web today, but there's also a lot of application types that people aren't attempting or aren't able to implement on the web because of some of these restrictions. And I think that the web has matured to the point now that we can begin knocking on those doors and say, why is that? The browser security model was done for safety's sake, and now maybe we have the time and the expertise to back up a little bit and say, well, maybe that was overly secure, maybe there's some safe ways that we can refine it and get these additional capabilities. Yes, sir.
I'll play devil's advocate also. Since .NET and CLR, well, the CLR is standardized, should that be pushed even more and follow to the smart client with the click once capabilities as applied with browsers?
Okay.
So just use the browser and the CLR as the platform.
Right.
Forget about which language, and then use that to drive the web, so that you have your low connectivity
Sure.
client and all that.
So the question or the observation is that with the CLR standardized multiple sources now, and would it make sense to look at CLR as being the field deployed piece that you write your apps for?
Plus, we click once.
Plus click once, that's correct. The answer is yes. And that would be, I don't think that's going to compete so much with JavaScript as with other environments that are downloadable into the browser, such as Flash. But absolutely, that if you could have,
Why shouldn't it compete?
because the infrastructure behind the CLR application development is much higher than JavaScript. You're not going to have high school students that are just ripping in script kidding stuff.
You could use JavaScript to write the applications.
Right, but you're not shipping the source code to the client, are you? You're shipping the CLR.
Yeah.
So you need to have a tool. Where's the tool needed for JavaScript?
Well, the SDK is free.
Okay, but there's a barrier of entry. You have to have these things installed.
Yeah.
Okay, so, but ultimately, yes, I would much rather have CLR on the client and not have to give this presentation about JavaScript. But the state of the world today is that JavaScript is the elephant. And how can we get the elephant to move, or how can we build on top of the elephant, or change the elephant's color, or something like that?
So Danny, I got a question. Who was the fellow that did the presentation yesterday with flapjacks? That thing. Syria. So did you install something on the browser side to make that happen?
Absolutely nothing. It'll run on your browser just like it runs on mine.
So where'd it come from? I mean, Danny.
It's just JavaScript code. JavaScript. It's in your browser.
So it's a library?
Yeah.
So you got basically the sample code that you had there in the page is referring to a library that does the magic behind the scenes on the client.
So there is something that you had to place on the client.
But it's pulled in by the fact that the user went to that HTML page. It's implicitly
okay.
pulled down.
It's a downloading control, and you just ask your browser to use flapjack script or.
Actually, what happens? I'm sorry, I don't want. Let me just answer that one
Yeah.
line. There's a compiler that takes a HTML page that includes flapjacks, turns to an HTML page that has JavaScript. And so then it's all pure JavaScript. There's no flat text anywhere in the picture. Put the JavaScript up on your server for, HTML page on your server and you're done.
So if you were to do a view source on the HTML, the pages there, what you'd see in view source is different from what you'd write as the source language.
Just what we were talking about, another language on top
Right.
of JavaScript.
Right. Okay. So I can take other questions offline, but I'm between you guys and the interesting stuff at the store. Okay. Thank you very much.